students, welcome back. This is Torres, elbow bump. How are you? Are you doing okay? Is your family okay? Remember, please email me, and I'm happy to help in whatever way I can. So lucky you get to hear my voice for another lecture. But the best part is we will be doing a review on how to check the assumption of normality using both measures of center and measures of variability. Yay! Let me remind you of some big important concepts. First, this is a reminder that mean, median, and mode describe how the data is alike. Measures of variability are the opposite. They describe how the data is different. Let's look at the measures of variability, specifically the 5-number summary. How that is described visually using the box whisker plot, the significance of the spread between the min and the max, also called the range, and the spread between the first quartile and the third quartile, also called the interquartile range. There are times where there are values that are very, very different than the majority of the data. Those values are called outliers. And if we look at this particular diagram, you can see that the outlier is this little asterisk. Each one of these vertical lines describe one of each of the 5 numbers in the 5-number summary. The box represents the interquartile range, and the range is the difference between the maximum and minimum values. The 5-number summary breaks up the data into 4 parts, and each part has an equal number of values. So it cuts the median cuts the data set exactly in half, so that 50% of the data is less than the median and 50% is more. And then the first quartile cuts it again in half between the median and the minimum, and the third quartile cuts it again in half between the median and the maximum. So you have 25% of the values here, 25% of the values here, 25% of the values here, and 25% of the values here. In this class, we've discussed 2 major types of figures. One of them is related to measures of center, the histograms. The histogram is a frequency distribution that shows how often something appears. The histogram shows a frequency distribution. So the bars tell you how often a value or a range of values appear within the data set. We want the mean and the median to be approximately in the center of the histogram. If there is an outlier, then a tail will form in the direction of the outlier. So here it's reasonable to believe that this outlier out here is pulling the mean and creating a left tail. Here we get the impression that there are outliers out here, and it is creating this long right tail, and the mean is moving towards the right. And here we see that there are more lower values and that the higher values sort of level out. In this situation, we expect the mean and the median to be about in the center. Here, the mean would be less than the median. Here, the mean would be greater than the median. And here, it would just kind of depend. It's probably somewhere kind of still a little bit to the center. There shouldn't be too much of a difference here. Okay. Now, the box plot does not use the mean. Recall, these are the values that are created to make a box plot, and the mean is not one of them. So we can review the box plot and have some idea of what's happening with the distribution as well. And this is just another way that we can further confirm normality. We want to just keep checking, keep checking, keep checking. If we have a normal distribution, you will see the median in the center of the box. The box is also called the H-spread. So you'll usually see the median right about the center of the box, and the whiskers will be approximately the same length. If you have a positive skew, then the median will likely be to the left of the box, and your right whisker may be longer than your left whisker. If you have a negative skew, then the median will probably be to the right, and more than likely you'll have a longer left whisker than you do a right whisker, although that's not what we see here. So do you see how this because the median is off to the right, that gives us some indication that it's a left skew, but still we're not getting that from the whiskers. So sometimes the information can contradict. That's why we just keep checking and checking and checking. We look for enough evidence to have some reasonable belief that the data is not skewed. So these are pairs of matched histograms and box plots. Here is a pretty normal distribution. Let me see, where's my pointer? Here we have a pretty normal distribution. If I were going to do an overlay over this, I would get something that looks like this. My median is in the middle of the interquartile range, and the whiskers are approximately the same length. So this does confirm on both the histogram and the box plot that there is reasonable belief that this distribution is normal. Here, we've got a left skew according to the histogram. So here in the box, we see that the left whisker is a lot longer than the right whisker. Okay, that would suggest a left skew. But when you look at the median, it's not exactly in the middle. It's just slightly to the right. Not a lot to the right, just slightly to the right. And all you really have to do is just report that. So you can just say that the median is slightly to the right of center within the interquartile range, and the left whisker is noticeably longer than the right whisker. Here we also have a skewed distribution. In this instance, we have a right skew, right? There's this number out here that seems to be creating this long right tail. When we look at the histogram, what do we see? We see a ton of outliers. That matches up with what we're seeing in through here, right? So we're seeing that, oh, there are outliers. There's several of them. All this data out here is very different than what is in through here. So here, the median is slightly to the left of center within the H spread, but there is a longer right whisker than left whisker, and there's several outliers. Here it's a little bit more difficult to tell, right? Here we don't really have a skew. We have something that's almost like a normal distribution, but with a few lower values here that are more frequently seen within the data set than these greater numbers out here. So what are we seeing here? Well, we're seeing that there is a bigger amount of variability. See how big the interquartile range is? The median is to the left of center. The right whisker is longer than the left whisker. Okay, now does this mean that this data is completely unsuitable for use? No, we don't know. We have to check numerically to see what it's telling us too. For all of these, we have to check numerically. It's not sufficient enough just to look at the data visually. So we want to go back just as before, as we did in the last chapter. We want to look at the data visually and numerically to determine if there is enough evidence that we can assume the normal distribution. Okay, so let's do a quick review of how to check the assumptions of normality, both visually and numerically. So when we're looking at the histogram, the normal distribution should have the following properties. It should be symmetric. So when we're looking at the histogram, we should see that the center, higher columns than the sides. It should taper down about approximately the same on both sides. It only has one mode. So again, the majority of the data is distributed within the center, and it should have like this mound or bell-shaped type of look to it. In terms of the visual examination of the box plot, in order to have some evidence that the distribution is normal, the box plot should have the median approximately in the center of the box, or the IQR if you want to call it that, or the H spread if you want to call it that, but ultimately we're looking for the median to be in the center, and the whiskers should be approximately the same length, and hopefully there are no outliers. If there are outliers, you can always look to see if they're balanced. So for example, if there's an outlier that is substantially lower than the majority of the data, and if there is an outlier that is substantially greater than the majority of the data, then they kind of tend to balance things out. So you can kind of look for something like that. In terms of checking the assumption of normality numerically, we're going to be looking at three main things. First, what is the relationship between the mean and the median? If the mean is approximately the same as the median, then that is some evidence that the data is normal. If the mean is less than the median, then that is some evidence that the data is left skewed. And if the mean is greater than the median, then that is some evidence that the data is right skewed. You also want to look at the skewness value. The acceptable range is between -1 and +1. If you have a skewness that is less than -1, then the data is excessively skewed. It's too skewed. And if you have a skewness value that is greater than +1, then the data is excessively positively skewed. Remember that the skewness value describes the shift from left to right. The kurtosis also needs to be checked. The kurtosis describes how the mound shifts upwards and downwards. So the acceptable range for kurtosis is between -3 and +3. If you have a negative kurtosis that is extreme, that means that the kurtosis value is less than -3 and the data has been flattened out. Another way to say that is the data is platykurtic. And if the data is too concentrated in the center, you've got a huge amount of frequency sort of like right around the mean and the median. It's very kind of pointed looking. The mode has been stretched upwards. Then you can say that the data is positively kurtotic or it's leptokurtic. So I want to use StatCrunch to reevaluate the professor salary example we worked with the last chapter, just to go over how to do the statistical evaluation using StatCrunch and also updating what we've already written so you can see how you add more to the checking of the assumption of normality. So as a reminder, the Google Sheet with the sample data is linked in the description box below, and I'm going to be using StatCrunch to evaluate the normality. And we're going to be writing this up as a statistical report. So here's my Google Sheets information. You can find the same Google Sheet in the description box below. And I'm going to go ahead and copy all this and put it into StatCrunch. So notice I am highlighting each one of the columns instead of trying to pull this down and select everything by hand. I'm going to go ahead and copy it, go into StatCrunch, open the website, and then I'm going to go ahead and click to where it says var1 and hit Control V, or if you have a Mac, remember that you can hit Command V, give you the same information. I'm going to go ahead and just kind of stretch this out so we can see everything in more detail and we're not missing out on any of the. Okay, so here's all my data. Let's go ahead and do the diagrams first. So I'm going to go to Graph, Histogram, select Salary. Remember, salary is the only quantitative variable and StatCrunch knows that already. I'm going to go ahead and do the overlay of the normal distribution, mark the mean and the median, and notice that mean is green. That's how I always remember it. And hit Compute, and I've got my nice histogram right here. I'm also going to go ahead and make my box plot by choosing Salary. A lot of the people prefer to draw the boxes horizontally instead of vertically, so I'm going to go ahead and do that. Mark the mean and the median and hit Compute. Now I've got my box plot and my histogram. I'm going to go ahead and just make this a little bit smaller so that we can fit it all in one place. So these are my visual comparisons, and then I'm also going to go into Summary Stats, go into Columns, select Salary, and I'm going to select the following: the sample size, mean, median range, min, max, Q1, Q3, IQR, skewness, kurtosis, mode, and hit Compute. Okay, and I've got all my information here. I've got the stuff that I can check my assumption of normality numerically, and I've got the figures that I need in order to check my assumption of normality visually. Last chapter, I also gave you a pro tip, and that was that when you're checking the assumption of normality, start to develop your own pattern for when you write your assumption testing. save it and just use it over and over again. And then as you want, you can always review it from time to time to see if you can make the writing a little bit better. I've tried to take this same advice into account as we worked with this new information. So here in black is the information that I just cut pasted from the last lecture on this. And here in red is the new information that I wrote in. So I'm just adding more to what I already have. Over here I have my original histogram, and I've also added the box plot below. So this is what I wrote. Professor salary data, n equals 87, was provided by Professor Torres on Google Sheets to determine if the data is suitable for statistical use. Visual and numerical methods were used to determine if there is evidence that the assumption of normality is met. StatCrunch was used to create the histogram and to calculate descriptive statistics. So this is the same thing that I wrote before. I wrote down what my sample size was, how I received it, that you got it through a Google Sheet, and what the purpose was. This all came in the first sentence. I wrote that I was going to examine this information visually and numerically, and the reason why. Finally, I wrote what kind of statistical software I use in order to create the figures and also to do the descriptive statistics. And if I were going to write something over again, I would write down to create the figures and to calculate the descriptive statistic. I kept the information about the histogram. The histogram is unimodal and the right tail is slightly longer than the left tail. There is an outlier that is much greater than the majority of the data. That stayed the same. That's what I wrote originally about the histogram. This is what's new. Visual examination of the box plot confirms this information. So I'm taking a sentence to say I'm seeing this again in the box plot. The median is slightly to the left of the IQR, and I wrote down the value here. And the right whisker is much longer than the left whisker. Here, the right whisker is a lot longer than the left whisker. There is also a visible outlier that is much greater than the majority of the data. Both figures suggest that the data is left skewed. So this is saying that this confirms one another, and they both confirm that it's left skewed. Now I'm going to continue writing up the information numerically. This hasn't changed. Numerical evaluation of the data confirms the data is positively skewed. The mean, I'm not going to read the number, is greater than the median, this number, which suggests a positive skew. This is confirmed by the skewness value, positive 1.67, which exceeds the acceptable range of positive and negative 1. The kurtosis 1.69, which describes how the width of the tails are affected by the height of the mode, is within the acceptable range of positive and negative 3 for normality to be assumed. In summary, the distribution of the data set is excessively skewed and the data is not suitable for statistical use. Here is the same information that I gave regarding the numerical calculations and how that would affect the shape of the distribution, and the last paragraph or sentence just gives the outcome that you would not suggest that this data be used for statistical use. Let's do one more example with the body temperature example that we worked with last chapter. Again, the Google Sheet is in the description box below. I'm still using StatCrunch to evaluate normality, and we will be writing up our evaluation in a statistical report format. Okay, so here is my information. I'm going to go ahead and select my data. Remember, I just like to highlight the columns so I don't have to drag down and I don't risk changing the data at all. I'm going to go ahead and copy that, go into StatCrunch and open up a new sheet. I'm going to click where it says var1 so that my headers will automatically be uploaded into this, and hit Control V. If you have a Mac, you're going to use Command V, and then I'm going to make the graphs same as before. Let me start by making my histogram. Program already knows that the only quantitative variable that I have is body temperature. It's put it up here for me to select. I'm going to use my normal overlay mean and median, and hit compute, and I have my histogram. I'm going to do the same thing to get my box plot. Click on the variable that I want. I'm going to draw the box horizontally, ask that the markers show the mean and the median, and hit compute, and now I have my box plot. Finally, I'm going to go into summary stats, hit columns, select body temperature, and then select the descriptive statistics that I like to use. So that's sample, mean, median range, min, max, Q1, Q3, IQR, skewness, kurtosis, mode, and then hit compute. And I have my output there, I have my box whisker right here, and I have my histogram in through here. So same as before, I went ahead and used the same body temperature data write-up that we used in the last chapter, and I just added more to it. So I have body temperature data, n equals 130, was provided by Professor Torres on a Google Sheet to determine if the data is suitable for statistical use. Visual and numerical methods were used to determine if there is evidence that the assumption of normality is met. StatCrunch was used to create the figures. Notice I changed histogram to figures this time, and to calculate descriptive statistics. So by making that change now, I can keep using this paragraph and just change things like the name of the variable, the sample size, how I got things, etc. The next paragraph says, the histogram is unimodal and the tails are approximately the same length or equal length. There are no visible outliers. The distribution is approximately bell-shaped and symmetrical, so that did not change. This is what's new. Visual examination of the box plot also suggests that the distribution is approximately normal. The median is in the middle of the H-spread and the tails are symmetrical, and the outliers are balanced, meaning that there's one outlier out here and there's a couple out here, but it's pretty balanced. Like it's, there's almost as many outliers that are greater than the majority of the data than are less than the majority of the data. Therefore, all visual figures suggest that the distribution of the data is approximately normal. Again, I kept the numerical evaluation paragraph about the same. Numerical evaluation of the data confirms the data is negatively skewed. The mean, x bar equals 98.2, is slightly less than the median equals 98.3, which suggests that the data is slightly left skewed. This is confirmed by negative skewness value of negative 0.004. However, since it does not exceed the acceptable range of positive -1, the distribution can be considered normal. The kurtosis, 0.78, which describes how the width of the tails are affected by the height of the mode, is within the acceptable range of positive -3, needed for normality to be assumed. In summary, there is ample evidence that the data is suitable for statistical use. I didn't have to change anything to it. So see how I started to develop a pattern of how I wrote this, and I just changed things as they needed to be changed for this particular instance. So what's the big idea? Today's big idea is that the shape of the distribution can be described visually and numerically. Descriptions of figures, like the histogram that we did before, and now what we know about box plots, as well as numerical outputs, describe if the distribution of the data is normal or if it's not normal. In order for us to apply the theories of probability to data that we've collected and make inferences about the population, the data must be considered normal. So that's why we check over and over and over again, because we need very strong, reasonable belief that the data is normal and we can apply these theories. So that's it for today. With that said, don't forget to check your emails, check Blackboard, do your homework, and subscribe to this channel. Even better, hit that notification bell so you know when there are new videos for this course. Okay? This is your teacher, Taurus, saying stay safe, and I will be waiting to give you a virtual elbow bump in the next video. Ciao!